Hello, I'm Ryan Cook, and this is Civic Tech Chat, a podcast about the civic technology movement. We seek to harness the power technology has to improve the delivery of public services to people everywhere. This week, we're talking education. For this breakdown, we're looking at the K-12 Computer Science Framework, a community-driven policy guide. The framework is steered by a committee of organizations, including the Association for Computing Machinery, Code.org, the Computer Science Teachers Association, the Cyber Innovation Center, and the National Math and Science Initiative. The framework consists of core concepts and practices. Concepts in this context are things students should know at various stages, and practices are things students should be able to do. It is grounded in a number of governing principles, such as equity, the empowerment of idea generation, a wide breadth of application practices, and the fostering of computational thinking. But why is this important? The subject is an increasingly unavoidable one in our world. The aim should be to give students the tools they need to get skills, understand the role computing plays around them, and how to apply what they've learned. Americans have started to see the value of this type of education as well. According to surveys by Google and Gallup, as well as Horizon Media, most parents want computer science courses to be offered to their children, and they also believe that the subject is just as important to learn as reading, writing, and math. Despite all this, there's still a gap between supply and demand. For example, Code.org found that since 2010, the Advanced Placement Computer Science exam has been among the fastest growing of those AP exams, though as of 2015, it had only been offered in just 5% of schools. So you might be wondering, what's in the framework? Well, it consists of 7 core practices, of which almost half are focused on the fostering of computational thinking. This is the thought process behind coming up with solutions using algorithms and/or computational steps. The full list of practices includes fostering an inclusive computing culture, collaborating around computing, recognizing and defining computational problems, developing and using abstractions, creating computational artifacts, and communicating about computing. Supporting the practices are 5 major concepts, or areas of computer science study. These are computing systems, networks in the internet, data and analysis, and the impacts of computing. These areas are supported with foundational knowledge as well. An example of this would be the idea of abstraction, which is the method one uses to distill a process down to points that can be translated for computational use. Another of these would be privacy and security, which is the consideration of how data is owned and controlled, as well as how it's kept safe. As you might imagine, both of those things tend to feed into each other. The framework provides an example of how a student might progress through one of these concepts, like computing systems. By the end of the 2nd grade, that student might begin to understand that computer systems are a relationship between hardware and software. As they've gotten through the 5th grade, that might expand to learning how hardware and software work together and how information is stored, sent, and processed as individual bits. By the time they reach the 8th grade, they could have delved into how design decisions for systems have trade-offs. Trade-offs can include functionality, cost, accessibility, and more. And by the time they finish the 12th grade, that student will have garnered an understanding of layers of interaction and how they relate to software, hardware, and the user. There's plenty of guidance here to be had for the policymaker as well, including a number of key reforms that are suggested to help accomplish all we've talked about. Officials should strive to define computer science as a topic area and to set standards for it in their schools. They should allocate funding for professional development for teachers and invest in the infrastructure to support them. They should provide incentives for those seeking to teach so that they could become qualified in computer science. They should create dedicated leadership positions in their education policy agencies. They should require secondary schools to offer computer science courses, and they should allow computer science to count as a graduation requirement, as well as a higher education admissions requirement. The big idea here is to have engagement with the topic from kindergarten all the way through high school graduation. This can take the form of the integration of core concepts into other courses like math and science, It can be independent courses offered at each grade level, and in high school, it could be the inclusion of introductory, advanced placement, and specialized courses such as cybersecurity or robotics. I cannot stress enough how important it is to engage in a conversation on this issue. Our government at all levels should seek to ensure our children are prepared to learn, compete, and thrive when they grow up. Students need to be able to explore their curiosities. I myself have been that curious student. As I grew up, I had to find my own way through the subject. But I was lucky enough to have family members in the field who could help guide me, teach me, and give me access to the tools I needed to learn. This simply isn't the case for everyone, and in my view, that is utterly unacceptable. To end this breakdown, I leave you with an ask. Go to K-12cs.org and learn about the framework. Start conversations with your neighbors about this topic. Reach out to your local leaders, your school board members, and your state legislators. Let them know how you feel. I can assure you that this type of advocacy works. I've seen it work. It is only through the inclusion of your voices that we can see reform across the country. You can follow us on Twitter using the handle @CivicTechChat, visit us on the web at civictech.chat, or subscribe to us for content updates wherever it is you download your podcasts.